come back. So quickly, we look into sum to infinity. But before we go deep into this, let me show you something. Watch this. 1, 3, 9, 27, 81, 2, 4, 3, 7, 2, 9. Yeah. Look at this. Look at this. 32, 16, 8, 4, 2, 1, 1/2. A, B. Look well. I have two sequences on the board. First one A, second one B. If you check very well, you will observe that the first sequence A, is increasing. Yeah. It's increasing. Yeah. Watch. Here is 1, 3, 9. Is increasing by a common ratio. 1 times 3, 3. Times 3, 9. Times 3, 27. Times 3, 81. We are safe to say the common ratio is 3. Yeah. The common ratio is 3. That's why the sequence is what? Divergent. When a sequence goes from small to big, from small to big is what? Divergent. When a GP, a geometric progression, a progression with common ratio is getting bigger and bigger, is said to be diverging. Look at the second sequence. Yes, it's also a GP because 6 divided by 2, 16, what am I saying? 8 divided by 16 is 1/2. Also, 16 divided by 32 is also 1/2. It has a common ratio. But in my second sequence B, you will clearly see that the sequence here is going from big to small. When a GP is going from big to small, it means that GP is converging. Yeah. And when a GP is converging, it means that we can add all these terms together. We can add all these terms together. This ... means we can add everything, including the subsequent terms. Like my next term should be 1/4, 1/8, and thereabouts. 1/16. I can add everything together. Adding everything together is what we call sum to infinity. Yeah. And the sum to infinity is very simple to evaluate. The sum to infinity is equal to the first term A all over 1 minus the common ratio. The formula for solving sum to infinity. Yeah. But the first sequence, which is diverging, the sum to infinity of a divergent sequence does not exist. Yeah. Before you can sum to infinity, that sequence must be convergent. For the sequence to converge, the common ratio must be less than 1. Yeah. This thing actually means from -1 down to 1. Numbers between -1 and 1. Yeah. So I am saying that you should know when you can sum to infinity. And what is that? When you have a proper fraction. When your common ratio gives you a proper fraction. Yeah. A fraction whereby the one on top is small, and the one down here is big. For instance, 2/3. 2 is small, 3 is big. Whatever your common ratio is a proper fraction. Yeah. The condition for your sequence, for your GP to converge. When we talk about convergent and divergent and sum to infinity, we are still discussing geometric progression, GP. Yeah. So quickly, I would want us to sum from 32 down to infinity. We'll sum everything. This plus this plus this plus this plus this plus even the ones we are not seeing. Let's sum all of them together and see what we'll get. How do we achieve this? We shall apply sum to infinity, which is the first term all over 1 minus the common ratio. The question is, what is my first term? My first term A is equal to 32. First term is what? 32. What's my common ratio? My common ratio is simple. The one you know, which is second over first or third over second. For me, I will go to where it is easy, which is this one over this one. I know that anything over 1 is that same thing. Yeah. Therefore, my common ratio is R equal to 1/2. If you're not cool with this, you can go ahead and do 2/4. 2/4 is 2 here, 1, 2 here, 2. The same thing, 1/2. So common ratio is 1/2. Sum. Someone I know, you. Whenever you have your common ratio and your first term, you can sum to infinity, provided your common ratio is a proper fraction, small, big. If your common ratio is bigger than 1, you can't sum to infinity. Before I can sum to infinity, the sequence must be converging. The sequence must be going from big to small. Yeah, that's it. So let's solve this. A 32 R 1/2. This means that the sum to infinity is A 32 all over 1 minus 1/2. Yeah. And this is 32 divided by 1 minus half. 1 minus half. 1/14, you remove half. Half will remain. Yeah. That will be 1/2. 32 by half. 64. But how would you know? Let me show you. This will be 32/1 times, we invert the fraction, 2/1, and that is 64. So when I sum this to infinity, my answer is 64. This class is short and brief. Just note that sum to infinity is the first term all over 1 minus the common ratio. And if I can sum to infinity, your common ratio in absolute value is less than 1. This means that minus 1 is less than r is less than 1. When we discuss inequality, we look into this properly, you have a deep understanding of what I mean here. For now, that will be the end of this class. Once more, this is Learn Extra, and I'm Hoggett Emmanuel signing out.